Hi, my name is Anna Massfeller. I'm a PhD student in agricultural economics at the University of Bonn. Here I'm presenting ongoing work from my co-authors and me on the effect of algorithm aversion on farmers' intention to use decision support tools in crop management. Reducing pesticide use in intensive agricultural production is among the main goals of the current agricultural policy of the EU. To improve pesticide application efficiency, farmers can use decision support tools. These tools help to optimize decisions under complex and uncertain conditions. Novel artificial intelligence-based tools exhibit enhanced data gathering and prediction abilities by considering real-time conditions, such as infestation pressures. Thereby, they promise to deliver improved recommendations for efficient pesticide application. Realizing these potential positive effects hinges on farmers' willingness to adopt such tools. Previous research revealed that most farmers prefer recommendations from advisory services and other farmers over those from smartphone applications. Thus, adoption of decision support tools is often lower than expected. Such reluctance against recommendations from algorithmic decision support is known as algorithm aversion. The phenomenon of individuals preferring advice from humans over advice from an algorithm, even if the algorithm outperforms the human. While this phenomenon is well studied in other contexts, it is not yet studied in the context of agricultural decision-making. However, with the ongoing development of AI-based decision support tools in crop production and their potential for improving efficient pesticide usage, there is a crucial need for understanding farmers' decision to use such tools. Therefore, we aim to explore and quantify the role of algorithm aversion and farmers' intention to adopt AI-based decision support tools for pesticide application. We focus on the specific case of fungicide application in wheat. In order to answer our research question, we conducted a pre-registered online survey with German arable farmers in autumn 2024, consisting of first, a theory-based part extending the unified theory of acceptance and usage of technology, and second, an experiment aiming at eliciting the farmers' willingness to pay for hypothetical advice coming from either an AI-based decision support tool or a human. In the preparation and analysis of the study, we followed a probabilistic programming workflow. This approach offers advantages for survey design and analysis. Specifically, it allows us to jointly analyze the theoretical and experimental part of the survey in one combined analysis. This can also be seen in the following directed acyclic graph, depicting our assumptions on the relations between our constructs and latent and observed variables. Developing such a conceptual model is an important step of the probabilistic programming workflow. Here in the upper part, you can see the theoretical part, in which we assume that besides social influence, performance expectancy and effort expectancy, also AI anxiety explains the behavioral intention to use AI decision support. In the lower part, the experiment is depicted, whereby we assume that the difference in the willingness to pay for a human and an AI decision support tool is a function of the difference in performance of these two advices, but also of AI anxiety. Hence, the red arrows show our coefficients of interest that we want to estimate, and that we define as algorithm aversion. Let me give you a rough idea of the experiment. Farmers can decide between two options for advice. All aspects like the way of interacting, the data used, and the type of information received in terms of timing doses and types of fungicides are the same. The only difference lies in who does the analysis of the data and derives the recommendation. In one case, it's a human advisor, in the other, an AI-based decision support tool. We further provide information on past correct recommendations. That means in how many past cases following the recommendation has led to improvements in the economic result. Each participant had to indicate 3 times the willingness to pay between 0 and 150 euro for both. A recommendation coming from the human and the one coming from the AI decision support tool, with 3 varying values for past recommendations. For the theoretical part, farmers had to evaluate statements on a 7-point Likert scale that allow us to proxy the latent constructs. Let's have a look at some preliminary results. We find that the majority of farmers in our sample exhibits a rather high AI anxiety. When we plot the difference in performance against the difference in willingness to pay, we would assume that an algorithm-neutral person prefers the human if it performs better and the AI DST if that one performs better, as shown by the black line. However, our results show that with increasing AI anxiety, these lines are shifted downwards, which means that people with high AI anxiety, shown in yellow, prefer human even if it performs worse than the AI decision support tool. We find a similar pattern for the theoretical constructs, where individuals with high AI anxiety, shown in yellow, exhibit a lower behavioral intention even if the performance expectancy is quite high. Based on our findings, we summarize that algorithm aversion plays an important role in farmers' intention to use AI-based decision support tools. Explanations for this observation might be the black box character of the tool, which might be a barrier to trust the recommendation. Further, farmers might fear to get a generic recommendation, not taking the individual farm characteristics into account. Evidence from other research shows that farmers seem to prefer advice from decision support tools, especially in combination with human advice, and when the tool allows to include own ideas and experiences. Given the increasing potential of novel AI-based decision support tools to improve farming efficiency, tech developers and policymakers should consider the role of farmers' algorithm aversion to promote the use of the tools. Advisory services should carefully check where to replace human advice by AI tools and where to rather complement them. A user-friendly design and financial incentives to use these tools might be ways forward. Thank you for watching. I'm looking forward to answer your questions and discuss this topic with you.